everybody. My name is Nkosina Timsedega. This is Bright Kaliati, and this is Miss Eunice Lipenga. So we are year 5 electrical and electronics engineering students. We are doing a project, automated water treatment, which is based on Kabijira water treatment plant at Kabijira power station, which supplies 105 households of employees. So basically, our project is automating manual operations of Kabijira water treatment plant, where we have this tank as our raw water tank. So we are mimicking the raw water tank, the incoming water from Chile. And then we have this tank is an aluminum sulfate dosing tank, which removes turbidity from water. And here we have the valves, which are linearly controlled, and here so we have also the dosing valve. And then the next tank, tank number 6, is the sedimentation tank, where the flocculation occurs when the coagulant mixes. And in the tank number 3, this is a soda ash tank, which collects the pH when it's ordered by aluminum sulfate dosed here. In this tank, tank number 4, we have chlorine, which removes microorganisms after we have dosed these 2 chemicals. And the 5th tank, we have the clear water tank, which collects treated water. So what we have found out the challenge at Kabijira was they operated valves manually. They didn't have a demand-driven system, where if the demand is getting high, it didn't check the water to adjust the inlet of the water. So basically what we're tackling is the automation of the whole system. So in the process of automating the whole system, we have developed a system, a monitoring system here, where we have the main dashboard. So the main dashboard basically is mimicking the whole system. So we have the raw water tank and the linear valve, which is that one, equivalent to that one, the flow sensor, equivalent in the middle, the sedimentation tank, the tank in the middle, tank number 6, the inline dosing, they are near the soda ash valve, and we have the filtration pump, which is a big black pump there. So basically what's happening here, you can control all the valves manually, or they can operate automatically when set in mode. On this window, we have the agitation motors interface, where we can control the rotation of the mixing of the chemicals in the chemicals tank. So we can operate various motors, as you can see there. So these are the various motors which are mixing the chemicals. So you can see chlorine is being mixed, soda ash is being mixed, and aluminum sulfate is being mixed. So you can switch off. So those are basically the controls of the agitators. So come this side again, and then we have the 3rd window, which is showing the trends, the data we are collecting. It's showing real-time variables of water level, turbidity, pH, the motor statuses, and the volume which you have dosed. We also have a separate database which is keeping our data, storing our data, so we can view multiple trends of the system. So one of the challenges we faced was acquiring linearly controlled valves. So these valves are manual valves, but what we have done is to solve that problem is to couple them to servo motors, so that you can adjust the opening of the servo motors. So another problem that we have is the time it takes for the coagulant to react is a bit longer. So the main system has bigger tanks, but we have small tanks, so we had to scale down to our system, which has been a bit of a challenge. So for further studies, we would recommend to develop new dosing valves which are accurate, which do not have some leakages as we have experienced, and involve people from maybe the chemistry department which are experts, so that we can accurately dose the system. I think that's all from this project.